Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Alia Izzian binti Basri with matric number 231160, and this is my group member. Our project is called Physics is Fun, and in this project we are going to show that physics isn't just about formulas and textbook, but it is actually things that always happen around us, and sometimes it is more exciting than we might think. Using fun stop motion videos, we are going to explore a simple yet powerful physics concept like optic, work, momentum, and also inertia. And each short tutorial is designed to make user to have a better understanding with real-life examples that they are able to relate to. At the end of every video, user will get to answer a set of short interactive questions that is designed to help them to recall what they have just learned, think deeper about how physics applies to real life, to challenge themselves just a little bit, and most importantly, have fun while doing it. In this page, user get to choose which video tutorial that they want to learn first. Here, we have optics, work, momentum, and also inertia. User can click the image and it will bring them straight to the video tutorial that they are going to learn.
I made the optic video. In the video, for the stop motion, I use a few tools, which is firstly, I use a laser pointer, a mirror for reflection, and then an empty transparent cup, a straw, and water for the reflection. For the reflection, I put the mirror on the table and then I use the laser pointer to point onto the mirror to make a reflection. While for the refraction, I put the water inside the cup and then I put the straw inside the cup so that we can see how the light bends inside the refraction. When a light reflected through a mirror, the angle which it hit the surface I is equal to the angle it bounces off R. When a light passes through one material to another, it bends because the light changes speed in different materials.
So for this tutorial, I will make it work. As everyone know, what our body and brain do is work. So what tools that I needed is first one is wagon, second one is ruler, third one is stone with different mass, which is the first mass is 5 kilogram and the second mass is 2 kilogram. So the step that I will do is first I will put the stone inside the wagon and I will pull it with same distance and same speed, which is distance is 3 meter and then speed is 2 meter. And then I will repeat into the different stone, which is 2 kilogram. How I calculate the result? First, I need to search for force, which is force is mass multiplied by acceleration, and then I will, after I got the force, I will calculate the work. Work is force multiplied by distance. So that's all from me. First, you need wagon. Second one is ruler. The third one, you need stone with different mass. This one is 2 kilogram. This one is 5 kilogram stone. First, measure it, make sure it's 3 meter and then pull it with 2 meter per second square. This one I'm using 5 kilo and this one I'm using 2 kilogram with same speed and same distance.
In the video, I used 3 toy cars, a marker and also a ruler to visualize how momentum works. In this short stop motion video, there will be a toy car going through 3 different scenes, and each scene shows a different part of how physics works in motion, like how forces act on the car, how it speeds up or slows down, and what keeps it moving or stops it. So at the end of each scene, there will be a short explanation to make the user have a better understanding.
Hi everyone, this video will talk about momentum. Now, what is momentum? Have you ever wondered why some objects hit harder than others? That is because of momentum, or a measure of how much motion an object has. Momentum depends on how heavy something is and how fast it is moving. The faster and heavier an object is, the more momentum it has and the harder it hits. In this video, we will explore how momentum affects collisions using toy cars and trucks. Let's see in action. We'll need 2 cars with the same mass and size, car A and B, a ruler, a marker, and a truck. Let's start with scene number 1. 2 cars with the same mass, with small push. We mark before the crash, then we push car A with small push. We mark it again, and we measure it. In the previous scene, car A moving at a moderate speed and crashing into car B, both with the same mass and size. This shows how motion and force are passed between objects of equal mass during a crash. Repeat scene number 2 with the same 2 cars but with a medium push. We repeat the same step as scene number 1, use medium push, mark it again, and then measure it using a ruler. In the previous scene, car A moves faster than before and crashes into car B. The mass of both cars is still the same but with a higher speed. Hence, car A has more kinetic energy and momentum. This shows that higher speed leads to a stronger impact, even with the same mass. In number 3, we are going to use a truck to hit the car, and also with a large push. Push the truck, and then after that mark the distance and measure it. In the previous scene, the truck moved at the same speed as car A did earlier, but it has much greater mass. When the truck hits the car, it barely slows down, while car A is pushed forward. This shows how a heavier object creates a stronger impact even at the same speed. Now, let's recap what we have learned. In scene 1, we saw how 2 cars with the same mass and speed had a small push. In scene number 2, higher speed caused a bigger push. In scene number 3, the heavier truck had more momentum and made the biggest impact. So remember, momentum depends on both mass and speed.
Thank you, Sister Izian. So my name is Nur Atira Izzah binti Azizan, metric number 2312652. I would like to present my individual stop motion tutorial titled Inertia. For my part, I have chosen inertia, which is based on Newton's first law of motion. The objective of my tutorial is to explain the basic concept of inertia using stop motion animation, a visual storytelling technique that combines photography and movement frame by frame. This method is especially effective for young learners, such as secondary school students, because it makes abstract scientific concepts more fun and easier to understand. My stop motion begins with a short introduction to inertia, where I explain that inertia is the tendency of an object to remain in its current state, whether it is at rest or in motion, unless acted upon by an external force. To demonstrate this, I use simple everyday materials such as a toy car, a flat table, a handkerchief, and a stapler. The first scene shows the toy car moving across the smooth surface of the table and then slowing down as it passes over the handkerchief. This demonstrates how friction acts as an external force that resists the motion, causing the car to slow down. In this part, I use frame-by-frame animation to clearly show the changes in speed. In the second scene, I push the same toy car forward again, but this time it collides with a stapler placed in its path. The car comes to a sudden stop, which helps to demonstrate how an obstacle or external force is needed to stop a moving object. This scene supports the main idea of Newton's first law: an object in motion will remain in motion unless a force stops it. Throughout the video, I added voice-over narration to guide the audience through the experiment, while also using text overlays on screen to highlight key points. The visual and audio elements work together to enhance clarity and engagement. At the end of the tutorial, I include a short recap to reinforce the learning objective. I summarized that inertia is not a force but a property of matters, and that changes in motion like stopping or slowing down always happen because of external forces such as friction or physical barriers. That concludes the stop motion tutorial on the concept of inertia. This demonstration aimed to visually present how Newton's first law applies to real-life situations using simple materials. Through this creative approach, the principle of inertia becomes more relatable and easier to comprehend, especially within an educational context. Welcome to this stop motion tutorial. Today, we are going to learn about inertia, which is part of Newton's first law of motion. This law explains how things behave when they are not being pushed or pulled. Basically, an object will remain at rest or keep moving in a straight line at a constant speed unless a force causes it to change. This tendency of objects to keep doing what they are already doing is called inertia. In everyday life, inertia is the reason why your body leans forward when a car suddenly stops. Here we have a toy car on a flat surface. When we push it, it starts moving forward. It continues in a straight line because of inertia, but as it crosses over a soft handkerchief, it begins to slow down. Why? Because of friction. Friction is a force that opposes motion, and in this case, it acts as an external force that reduces the car's speed. Without friction, the car would keep rolling forever. The toy car is rolling again, but this time there's a stapler in the way. The car crashes into it and immediately stops. This demonstrates that motion doesn't stop on its own. Something like a wall, an obstacle, or a person must apply force to change the motion. In this case, the stapler provides that force. This again proves Newton's first law. An object in motion will stay in motion unless something causes it to stop. So, what have we learned? Inertia is the neutral tendency of objects to resist changes in their state of motion. Objects won't start moving unless you push or pull them. And if they are already moving, they will keep going unless something makes them slow down or stop, like friction or a barrier. This is what Newton means in his first law of motion. Understanding inertia helps us explain many things around us, from why seatbelts are important to how planets stay in orbit. To conclude our group project, we developed a stop-motion based e-learning series titled Physics is Fun, which focuses on 4 fundamental physics topics, which is optics, work, momentum, and inertia. The main objective of this project is to present scientific concepts in a way that is visually engaging and easier to understand, particularly for secondary school students. By using stop-motion animation, we turn complex theories into simple visual stories, making the learning experience more interactive and enjoyable. Throughout the project, Each group member was responsible for producing one tutorial. We applied multimedia development skills in every stage, from planning and scripting to filming, narration, editing, and post-production. The result is a series of educational videos that combine visuals, narrations, sound effects, and creative presentation to support better comprehensive of physics. This project not only allowed us to apply technical and creative skills, but it also deepened our understanding of how multimedia can be effectively used in educational contexts. It is our hope that these tutorials can serve as an alternative learning resource that encourage curiosity and help learners connect with science more meaningful. That's all from us. Thank you.